In order to answer this question, you need to think about the two trigonometrical ratios, tan theta and cos theta, and also Pythagoras' theorem. So we're going to start by looking at tan theta in the equation that we want to prove, and tan theta is equal to opposite divided by adjacent in any right angle triangle. Here we're thinking about the angle theta, and the opposite side is B and the adjacent side is A. So that means that tan theta is equal to B over A. So if we then look at cos theta is equal to adjacent over hypotenuse. In this particular triangle, then the adjacent is A and the hypotenuse is C. So that means that cos theta is equal to A over C. If we look at the left-hand side of the equation that we're trying to prove and work on that, then we have 1 plus tan squared theta is equal to 1 plus, and we said tan theta was B over A, so B over A squared. We can rewrite that as A squared over A squared plus B squared over A squared, which is A squared plus B squared all over A squared. You might notice then that A squared plus B squared is what we have from Pythagoras very often. So if we replace this with using Pythagoras, then we can replace this A squared plus B squared with C squared, the hypotenuse, over A squared. Now, if we take that onto another slide, so we've got a bit more room, we'll just move up the page. I wonder if I can move up the page. Yep, move up the page. Then we can say that 1 plus tan squared theta equals C squared over A squared. Let's go back to the original question, look at what we're trying to prove. So we've worked on this side and we've got to a particular point. Let's work on this side and see what that gives us. Go back down. So we're now trying to work on 1 over cos squared theta. So if you look back at what we did before, we said that cos theta is A over C, which means that cos squared theta, let's write that down, cos squared theta is A squared over C squared. 1 over cos squared theta is the reciprocal of cos squared theta. Here's cos squared theta. The reciprocal of it turns the fraction upside down. So we get C squared over A squared. If we tie all of that together, you'll see that the expression we ended up for tan squared plus 1 is the same as the expression that we ended up with for 1 over cos squared theta. So therefore 1 plus tan squared theta equals 1 over cos squared theta, as we were asked to prove. This is not a straightforward question, and seeing what to do is quite difficult, but it's one of those questions where it's worth trying something. You've got a right angle triangle. You know all sorts of things about right angle triangles, and you know lots of things about tan and cos and Pythagoras. So writing down some of those things might give you a starting point from which then to work. It's not worth a huge amount of marks, so that either implies they don't want to heavily penalise you if you can't see it, or that they don't actually think it's that difficult once you see what to do.